So for these here, for the first one, what do you do with the 8? Answer is nothing. You move it. The 8 is going to stay your whole number. So it's just the 0.333 we're worried about. We put it over 1, and then what? Times 16 over 16. So this is 5.33 over 16, which is how many sixteenths? 5. Very good. This 5.33 is between 5 and 6. Closer to the 5. How many of you had 8 and 5 sixteenths? Anybody have questions on how we got there? Does it look familiar now? Okay. Yeah, you got to get it to the 5 sixteenths. You got to.
Well,
I mean, yeah, if you had it as
3.125.
okay, that's fine. Yeah. We're converting it here because that's the tool size you'd be looking up if you're pulling a standard tool out to make that hole or whatever it is. Okay, for the next one, there is no whole number. So we just have to take the 0.121, put it over 1, and we want it to the nearest 16th. So 1 times 16 is 16. 0.121 times 16 is 1.92636. That's between 1 16th and 9 16ths. It's closest to 2 16ths. So that's 1/8. Yes, we can still simplify it, because if you're looking for a tool, the tool wouldn't be listed as a 2 16ths, it'd be listed as a 1/8. Any questions on those two? 0.694. Put it over 1. Now we're going to multiply by 8 over 8 because we want to the nearest 8. So that's going to be what? 5 point. $5.552 between 5/8 and 6/8, closest to 6/8. So that reduces to 3/4 of an inch. And finally, 2.281. We're going to keep the 2. 0.281 over 1 times 8 over 8. We get 8 there. 0.281 times 8 is 2248. 2.248, which is closest to 2/8, which will reduce to 1/4. Any questions? Okay, so we left off last class. We talked about these length measurements.
Oh, I got one question.
Yes.
I did 281 divided by 1/16 or 1/8.
Okay.
And I got 18 and 0.248. And then I just leave the 18 and this 0.248 over 8. So I got it right, but I didn't put it into a
So it'd be 18 and
0.248.
so just leave it as 18 over 8 and then reduce it down. You could do that. Yeah, it's just an improper fraction, the 18 over 8. Then you reduce that to 2 and 2/8, which is 2 and 1/4. That does work. It's just once you divide it, you divide it by 1/8, then you got to round off the decimal. So it's 0.2, so that means you round it down, so you leave it as 18. If it had been 0.5 or above, you'd round it up to 19, and then you'd change it from an improper fraction to a mixed number. But yes, that does work. Okay. So we're talking about these measurements. First, I want to review our metric measurements. We have our meter in the center of our chart. As we go to the right, what's the next smaller unit from meter? What's the 1/10? Careful. Decimeter comes next. then centimeter, then millimeter. Then, of course, it skips a couple spots. Then we have the micrometer. If we skipped a couple more spots, we didn't talk about this one yesterday, but then it'd be nanometer. You hear about nanometer a lot, nanotechnology. In the last couple of years, it's faded, but 6-7 years ago, you heard a lot about nanotechnology and all that. All that is the technology of working with stuff that's really, really tiny. Nano machining, nanochemistry, and things like that is what that is. It's basically doing things that are like, instead of dealing with materials, you're actually assembling them atom by atom to create stuff. It's kind of cool, but they haven't come up with a practical use for a lot of it yet. Going the other way, going larger, smaller than a meter, or larger than a meter, we have decameter, which is DAM, because DM is already for decimeter. What's next? This one doesn't get used a lot. Hecto is 100 meters. Then kilo. Then it skips a couple spots. Then it's megameter. Skips a couple spots. Anybody know what's after mega? Giga. If you're into computers, you got kilobytes, megabytes, gigabytes, and then it would be terabytes. Mega is a million, giga is a billion, tera is a trillion. In computers, it's very useful. In meters, it's not so much. A kilometer is 1,000 meters. A megameter is 1,000 kilometers. Well, a megameter isn't very useful because the equator of the Earth is only at 25,000 kilometers. So, it's not terribly necessary. What's that? An astronomical unit. Yeah. So anyway, HM is a hectometer. In practice, obviously the meter gets used, and most of the time the units that get used are kilo and milli. Then for the really small stuff, micro gets used quite a bit. Mega is just too big in most cases to be used no matter what unit we're talking about. And in most of the units we talk about, when we start talking about volume, mass and stuff, kilo, the standard unit, kilo and milli are the ones that get used. Now when it comes to length, centimeter gets used quite a bit in the United States. In other countries, it's not so popular. It's just the meter and the millimeter. In the United States, we tend to use the centimeter a lot, only because it's the closest thing there is to an inch in the metric system. There's 2.54 centimeters in an inch. So it's not even really close, but it's as close as they get. And the inch is so ingrained in us in the United States that we use the centimeter a lot. But in other countries, it's not so much. They came up with all these units thinking they'd be useful, and they found out that, well, because it's such an easy decimal transition, that the intermediate ones like hecto and deca almost never get used. Like I said, centi gets used a little bit for meters because in the United States it's closest to the inch. Centiliters gets used a little bit in blood testing. Deciliters actually gets used in medical blood testing. Like if you go in and have your cholesterol checked, and we'll talk about liters after a while. If your cholesterol comes back at 190, that's 190 milligrams of the triglyceride per deciliter of blood. Or if your blood sugar comes back at an 87, that's 87 milligrams of blood glucose per deciliter of blood. So those units get used in specialized application, and that's about it.
Why do you know all these things?
I've been around the block a couple times.
Full
Useless knowledge?
Yeah. No offense.
Oh, I understand. I had a period in my career where, well, up until I started working here, the longest I'd ever been at a job was 27 months. Because in engineering, you bounce around. I mean, you work at a place till you make a name for yourself, and then one of their competitors hires you away and gives you a big raise. That's just how, I mean, I had jobs that I only worked for like 13 or 14 weeks. So I've been around the block a couple times. So anyway, let's review our conversions here. If I have 2.87 centimeters, I'm converting to millimeters. You guys remember how to do that conversion? Times 1,000? Well, from centimeters to millimeters. Where's centimeters on our chart? Right here, right? Millimeters is here. To get from centimeters to millimeters, we're going how many spots? One spot. Every spot on this chart is multiplying or dividing by 1,000. So, we're moving over, or not 1,000, by 10. So yeah, multiply or divide by 10. So I moved over one spot to the right. I'm moving the decimal point one spot to the right. So it's 28.7. Make sense? So what if I have 930 centimeters and I'm going to meters? Okay, we're going from centimeters to meters is 2 spots to the left. Decimal point goes 2 spots to the left. So yeah, dividing by 100 is basically what you're doing. If I have 34 millimeters, and I want to convert it into meters, what am I going to do? Well, from millimeters to meters, I'm going 1, 2, 3 spots to the left, right? Decimal point has to go 1, 2, 3, have to add a 0, spots to the left. 0.034. Pretty much, yeah. The other way you could look at it is this. If you look at this chart, meter is 1, right? A decimeter is 0.1 meter. Centimeter is 0.01 meters. Millimeter is 0.001 meters. Decameter is 10 meters. Hectometer is 100 meters. Kilometer is 1,000 meters. So I could do like I did with standard units. If I have 34 millimeters, and I want to convert from millimeters to meters, I'm going to multiply. 1 millimeter is 0.001 meters. So the millimeters cross cancel out. It's 34 times 0.001. Now in the metric system, since it's basically just moving the decimal point, I just use the chart and I move the decimal point. If you can remember the chart, that's great. If you can't remember the chart, well then you'll have to start remembering, okay, milli is 1,000th. So 1 millimeter equals 1,000th of a meter, and you can use that. In our standard units, we have to do some sort of conversion factor. If we have (84 inches), how many feet is that going to be? We're going to set it up. Most of us know to get from inches to feet, just divide by 12. But the way it would be set up is like this. It's 84 over 1. We're getting rid of inches, so inches go on bottom so they'll cross cancel. So that means feet have to go on top because that's the unit we're converting it into. 1 foot is 12 inches. So the inches do cross cancel. 84 times 1 is 84, and it's feet. 1 times 12 is 12, so 84 divided by 12 is 7 feet. Make sense? Why do we bother doing that? Well, because, I mean, with feet, inches, and even yards for most of you, we're familiar enough with it that we could just say, hey, we're going to divide by 12, or multiply by 12, or divide by 3, or whatever. But I showed you yesterday we had units like the rods, and there's furlongs and stuff like that that we're not quite so familiar with. If I told you we have 4 rods, and I want to know how many yards that is, can anybody tell me just right off the top of their head, what do you do? Okay, you do multiply. First of all, how would you know that you multiply?
5.5 yards.
Okay. If you look at the units, as I go from rods to yards, is that unit getting bigger or smaller? Smaller. A yard is smaller than a rod. The unit's getting smaller, so the number has to get bigger. So we're going to have to multiply the number. But the formal way of doing this For separate fraction, rods will go on bottom, yards on top. 1 rod is 5.5 yards. So the rods cancel out. 4 times 5.5 is 22 yards. 1 times 1 is 1. So it's 22 yards over 1 or just 22 yards. So yes, you do multiply by the 5.5. And again, that's a way to double check it is just what I did here. Yards to rods, or rods to yards. The units are getting smaller, so that number better get bigger. If the number also gets smaller, then we know we did something backwards. We divided when we should have multiplied, or the other way around. Whatever happens to the unit, the number has to do the opposite, because the total size has to stay the same. Think about it. If you're using a smaller unit, there's going to be more of them. Another reason why we use that conversion is, what if I tell you that 1 kilometer is 0.6 miles? So I want to know, if you're going to run a 10 kilometer run, how many miles is that? That's a convert. Yeah, it is. But it's not one of those conversions you know right off the top of your head. So put 10 kilometers over 1. Which, that one, yeah, you got it. Which one goes on bottom over here? We got kilometers or miles. Which one's going to go on bottom? Kilometers. Whatever's here has to go on bottom here so that they cross cancel out. And we know that 1 kilometer is 0.6 miles. So that cross cancels. 10 times 0.6 miles is 6 miles. 1 times 1 is 1. So this is 6 miles. What do you think? Good? Okay. So I want you guys to convert for me. If 1 inch equals 2.54 centimeters and 1 meter equals 39.37 inches. I want you to convert for me 32 centimeters into inches. Two feet into centimeters. 3 meters into feet. I want you to do those 3 for me quick. So for the first one, we got 32 centimeters over 1. What's going to go on bottom over here? What units? Centimeters. What's going to go on top? Inches. So they're going from centimeters to inches. So what number goes on top? 1 goes with inches, right? 2.54 goes with centimeters. So the centimeters cross cancel. This is 32 inches over 2.54. So it's 32 divided by 2.54. 12.5 works for me. 12.6. I'd say 12.60, yeah. Now, 2 feet to centimeters. Do we have anything that relates feet to centimeters? We have inches to centimeters and meters to inches. But 2 feet, we can very quickly convert to 24 inches. Over here, what's going on bottom? Inches. And centimeters will be on top. 1 inch is 2.54 centimeters. So the inches cross cancel. We've got 24 times 2.54, 60.96. How many of you had the first 2 right? Any questions? Or? Okay. Bottom one now. 3 meters into feet. Again, we don't have meters to feet. We have meters to inches. So let's convert meters to inches. Do 3 meters over 1. Meters. 1 meter is 39.37 inches. So the meters cross cancel. 3 times 39.37 equals 118.11 inches. Now we got to convert that into feet. 1 foot is 12 inches. So basically that's telling us we're just going to divide that by 12, right? 9.8425, 9.84 we'll call it feet. What do you need? The 39.37? That was good. So if I need to measure something, we're just going to go through this really quickly because I'm confident you guys know how to do it. I want to measure the length of that line. What I'm going to do is I'm going to take a ruler, and I am going to line it up. Now the zero end of the ruler has to line up with one end of the object I'm measuring. So this would be the zero end. And then of course there's marks. We've talked about the marks before, right? You can't estimate between the marks. Whatever mark it's closest to is the one you call it. So now it might be 8/16 16ths or whatever. Usually in a problem, if I'm asking you to measure something, I'll say measure it to the nearest 1/8 inch or nearest 1/16 of an inch or whatever, or 1/4 inch. So once you get the zero end of the ruler lined up, now be careful. Not all rulers have the zero at the very end. Some rulers might look like this, where the zero is slightly in from the end. And one of the reasons they do that is the ends tend to get worn down and rounded off over time. So they put the zero in a little way, so now you're going to line up the object at that 0 point, so it doesn't matter if the end gets wore down, the zero isn't going to be affected. That's why a lot of rulers are a little bit off, because if the zero is right at the end of it, over time that end gets wore down and eroded away. And so it's a little touch shorter if you need to do a really precise measurement. That's why a lot of people say rather than lining it up at the very beginning of the ruler, that you should actually start, get back here, line it up with the 1, and then just subtract 1 from your measurement. I'm not going to make you do that, but for real precision measurement, sometimes that's a better way to do things. For in here, if you want really precision measurement, in a little while we're going to learn how to do calipers and micrometers, and that's the better way to do the really precise measurements. But what now if I wanted to measure a circle? Well, the easiest way is if I'm showing the center of the circle, then I'm just going to take a ruler and I'm going to put the zero end on one side and run the edge of the ruler that I'm reading the measurement off of so that it goes through the center. Then whatever's over here, that's the diameter of the circle. You got to be really careful. If that center of the circle is not marked, well, then you do the same thing. You put the zero end on one edge of the circle. Then you have to slide your ruler back and forth and watch where the reading is. And wherever that reading is the longest, that's where you measure it at. Does that make sense? I mean, it's kind of tough. I mean, it's best if you have the center of the circle marked, but there will be some that we measure that the center won't be marked. If you can make it accurately. Yeah, if you have the protractor and all that stuff, you can make the center. Yeah, you won't always have a circle that's the same size. Most of the methods that involve making arcs to find the center of a circle require you to have a diameter of the circle to begin with. Yeah, I mean, if you want to go through that, you can. It's definitely a lot more accurate than this, yes. And in practice, if you're measuring a circle, generally it's going to be a solid object, not something printed on a piece of paper. So you're just going to take a caliper and clamp the jaws of the caliper around it, so you're definitely getting a diameter then. We're just looking at when we're doing crap on paper, how can you make it work? So parts of the circle then that you're going to need to know. We've already talked about perimeter of an object. This is for a rectangle, not a circle, but for the perimeter of a rectangle, it's just 2 times the length plus 2 times the width. Or you could do the length plus the width and then multiply that by 2. It comes out to the same thing. For a circle, its perimeter is called a circumference. And you find the circumference of a circle, the perimeter of a circle, by taking pi times the diameter. So that's why we had to be able to measure that diameter up there, is because to find its circumference, the distance around, it's pi times the diameter. What is pi? So we've estimated it with 3.14. It's 3.14159. It goes on forever, right? I think we've estimated it out to like 20,000 digits now. For our purposes, you can either use 3.14, or on many of your calculators, you'll have a pi key. Like here, this calculator has a pi key right there. Either way is fine. When I do my answer keys for quizzes and tests, I use both numbers so that I have both ways, because it will be a different answer. If you use the pi key, it's going to round differently, of course. In your homework, it's going to tell you what to use for pi. Okay, so for homework for tomorrow, we are still in the in that packet. Unit 19 in the packet. I just wanted to take today to clean up some of the things that we hadn't covered real well yet.